Very good morning, students. In the last video class, we were discussing tests for adequacy of index numbers. In that, we had completed unit test and time reversal test. So today, next test we shall consider, which is factor reversal test. Last video class we had come across time reversal test, wherein time was reversed, which means current year and base years were interchanged. Here now today we will be discussing factor reversal test. Which are the factors we consider? Price and quantity. Those are the factors. Current year and base years were time periods. Factors in the sense price and quantities, we consider them to be factors. So factor reversal test. Here we will be interchanging price and quantities. Let us know what the procedure is exactly. Factor reversal test. So this factor reversal test requires that the product of price and quantity index numbers should be equal to the corresponding value index number. What it requires? Factor reversal test. This factor reversal test requires that the product of, that means multiplication of, price index and quantity index number. For a given data, if you calculate price and quantity index numbers, and then further if you take the multiplication of those two, it should be equal to, or it should be resulting in, corresponding value index number, which is nothing but, in terms of notation, here you can observe P01 multiplied by Q01 is equal to V01. What is P01? It is price index number in current year 1 as compared to base year 0. And what is quantity index number? It is Q01, which is nothing but quantity index number in current year 1 as compared to base year 0 is equal to V01, which is nothing but value index number. So what it states? The product of price and quantity index numbers. Is it not a product of price and quantity index numbers? Because it is considered here multiplication, which should be equal to the corresponding value index number. These two price and quantity index numbers product should be resulting in value index number. Then it will be called as such index number, like satisfies factor reversal test. It means that the changes in the price multiplied by the changes in the quantity should be equal to the total change in the value. Index number is nothing but change in, price here in current year as compared to base year we will be observing. So whatever the changes in prices, it has been taken in current year. When you compare it with base year, it will be considered as price index number. Similarly, quantity index number also, it is the change observed in quantity level in current year as compared to base year. So that's why in the other words it has been said that the changes in price multiplied by changes in quantity. Here price index number is nothing but change in price. Quantity index number is nothing but quantity, changes, which is resulting in corresponding change in value. change in value in current year as compared to base year. In that context, this second paragraph has been given. Either the first paragraph or in the second paragraph, whatever it is given, any one of these you can use to refer to factor reversal test. Laspier's, Paschet's, Marshall Edgeworth's, Dorbish-Bowley's and Kelly's index numbers do not satisfy FRT. FRT is nothing but factor reversal test. All these index numbers will not be following or will not be satisfying factor reversal test. Only Fisher's index number will be satisfying factor reversal test. Let us see the proof of these, why these index numbers will not satisfy FRT and why only Fisher's index number will be satisfying FRT. It is in the similar way how we have done based on time reversal tests. Many of the proofs we have observed based on the index numbers, basic formula, when times were interchanged, what was it resulting in, whether it is resulting in 1 or not, basing on that, whether the given index number satisfies time reversal test or not. That we had already done in the last video class. Now we will be observing in the similar lines, but we are checking for factor reversal test. So first, Laspier's method, let it be considered. Laspier's price index number formula we know already, it to be P01L is equal to sum of P1 divided by sum of P0 format, and Q0 and Q0 is the weight applied. So this is what is Laspier's price index number. Since we are checking for factor reversal test, wherever P is there, therein it has to be replacement with Q. Time is remaining constant, in the sense whatever it is present here, the same time will be retained, but only the factors will be changed. For example, here P is there, that's why it has to be changed to Q. 1 as it is, I have to keep it. Here Q is there, that I need to change to P. Factors are being reversed. And 0 as it is being taken. Here P is there, that's why here Q to be taken, and 0 as it is. And here Q is there, that has to be done as P, and 0 as it is to be considered. Once when we change these factors, what will it become? It will become quantity index number. That means Laspier quantity index number is given by Q01L, which is equal to summation of Q1 P0 divided by sum of Q0 P0. So what we got now? Price and quantity index numbers of Laspier's method. What we know the condition to be satisfied for factor reversal test? Product of price and quantity index number should result in value index number, isn't it? So now let us consider, according to factor reversal test, we know P01 multiplied by Q01 is equal to V01. According to that, substitute subsequently the given, or the obtained formulae. First P01 to be substituted here, so that this is the P01, substitute that, multiplied by quantity index number is there. So multiplication as it is you keep, and quantity index number is nothing but, here we have written quantity index numbers based on Laspier's method, that also to be written. When you multiply these two, whether it is resulting with RHS V01, V01 is nothing but, we know already, sum of P1 Q1 divided by sum of P0 Q0, correct? That's why here sum of P1 Q1 divided by sum of P0 Q0 has been written. Whether this side, LHS side and RHS side will be equal, I mean to tell, when you multiply price as well as quantity index number, is it going to be sum of P1 Q1 divided by sum of P0 Q0? You can observe here. sum of P1 Q naught multiplied by sum of Q1 P naught. When you multiply these two, will it be resulting in sum of P1 Q1? No, obviously, correct? So a denominator also, when you are multiplying, sum of P naught Q naught, and here also sum of P naught Q naught is there. Whether it is resulting in sum of P naught Q naught when you multiply these two, no, it is resulting as sum of P naught Q naught the whole square. But value index number we should get in the denominator sum of P naught Q naught. So this multiplication, price index number and the quantity index number multiplication which we have observed, is not resulting in or not equal to value index number. That is why we are writing, therefore Laspeyres index number does not satisfy FRT. In the similar lines, when you consider Pasch-Chase, Marshall-Edgeworth's, Dorbish-Bowley's and Kelly's index numbers. First writing price index number, next quantity index number, then multiplying those two price and quantity index numbers, checking whether it is resulting value index number. If it is resulting in value index number, then it will be satisfied FRT, factor reversal test, otherwise no. When you perform for all these index numbers, right from Pasch-Chase, Marshall-Edgeworth, Dorbish-Bowley's and Kelly's, you will not be able to get the RHS sum of P1 Q1 divided by sum of P naught Q naught. That's why we tell they do not satisfy factor reversal test. And one more fact in the previous slide we have observed. Then which is the index number that satisfied by factor reversal test is only Fisher's index number. That we shall observe, how it is satisfying factor. Fisher's index number. We know already Fisher's price index number is written as square root of multiplication of Laspeyres price index number and Pasch-Chase price index number. Here also multiplication of 100 will not be present, as we have observed in case of TRT. That means in terms of time reversal test and factor reversal test, that constant of proportionality is not being written, in the sense it's not being multiplied by 100. Next, based on this Fisher's price index number, when we write it to be quantity, we know the formula of quantity index number also, that is different matter. But what we are concentrating now, since it is factor reversal test, factors are to be interchanged. If one factor is there as P, it has to be changed as Q. That means price to be changed as quantities and quantities to be changed as prices. So here P is there. Is it not the reverse has been written here in terms of Q? That means Q01F is nothing but under the square root, wherever P was there it has to be replaced as Q. Wherever Q is there, that has to be replaced by P. 0 and 1 to be taken as it is here. In terms of time reversal test, we used to interchange 0 and 1 by keeping P and Q as it is. But it is factor reversal test. That's why P and Q are to be changed, interchanged, and we need to retain as it is 0 and 1s. Once after performing that, we will get price as well as quantity index numbers. We know according to FRT or a factor reversal test what it is to be satisfied. P01 multiplied by Q01 should be equal to V01. V01 is nothing but sum of P1 Q1 divided by sum of P naught Q naught. So multiply these two price and quantity index numbers based on Fisher's method first. Since both are under square root, they can be written in a single square root. So P01 multiplied by Q01 has been shown in a single square root here. This entire formula has been written first in these two expressions, and this also, expression has been written in this second half. After that, what happens? Here in the numerator, P1 Q naught is there, correct? In the denominator where P1 Q naught is there, try to observe here P1 and Q naught is there. Sum of P1 Q naught here in numerator and sum of P1 Q naught here in denominator are same, so that these will be getting cancelled. Next, in numerator here, sum of Q1 P naught is there, and in the denominator once again Q1 P naught where it is present here, sum of Q1 and P naught. So these two again will be getting cancelled. So what is remaining? In numerator, the sum of P1 Q1 and the sum of Q1 P1, which can be written as sum of P1 Q1 also. So these two are remaining, and in denominator what is remaining? Sum of P naught Q naught is remaining, and then sum of Q naught P naught is remaining, which can be written as P naught Q naught also. So here under the square root, in next step what happens? The sum of P1 Q1 multiplied by sum of P1 Q1. It is taken as sum of P1 Q1 the square. And next here sum of P naught Q naught, and here once again sum of P naught Q naught is there. That's why the sum of P naught Q naught the whole square is taken. Since both numerator and denominator is in the format of square, that can be written as whole square also. So under the square root, this term, the whole square is present. So this square and square root will be getting cancelled. It will be remaining as sum of P1 Q1 divided by sum of P naught Q naught. Is it not the expression of V01? Yes. That's why we write or we conclude Fisher's index number satisfies FRT, or a factor reversal test. Hope you are following me, students. In the next class, we shall see further what all we can study. Thank you so much. Take care.